Hello everyone, welcome back to Tametsi. It's been a while since we solved a puzzle without stumbling. What puzzle were we even on? I'm so lost. I don't understand how to read this grid. I think we might be doing 49 next. Yeah, did we just do 48? Yes. Yes. This looks familiar. Okay. So 49. A snowflake. Yeah, that's what it says down there. More of these, like... I remember this layout from Hyper Rogue, right? Kind of alternating hexagons and triangles. It makes for very curious movement because triangles are only next to hexagons and hexagons are only next to triangles. It's like navigating on the 2D plane, except that you can only move up. You can't move diagonally. So you have to move in a compass direction. And it seems very strange that something like this would be roughly equivalent to just like an orthogonal grid, but I think it is. I don't know, maybe I'm wrong. It felt similar in Hyper Rogue, but I guess it's different here. Because they already have the ability to just give us a 2D grid and say the corners don't count. This must be something different. Yeah, obviously it is, because this has 6 next to it, and you don't have that in the 4. But okay, it felt very similar in Hyper Rogue. Anyway, so this 2, we have these. Very nice. This 1, okay, nothing there. This 4, we can't quite finish. This 2 goes here. I don't see anything else easy. So I guess we're meant to start counting A's and B's. Right? Like, to figure out how which way some of these 1s are going. The only way I see to do it is if we could, for example, conclude that, suppose we said, okay, this B has to be a mine. Oh, I should use a pencil. If we could somehow say, oh, this B has to be a mine, then these A's would both be free. Or, if we said this B can't be a mine, then both those A's must be mines. And the only way I can see to make arguments of that sort is by mine count. Because there's just not enough interesting pieces next to each other, like sharing borders. We have to do it indirectly. For example, well, actually, I kind of want the pencil. We have at least one of these 2 A's for the 3 to be satisfied, right? And at least one of these 2 A's, and at least one of these 2 A's, and at least one of these 2 A's. And that's all 4 of the A's that we're allowed to have. So, everything above this row of the puzzle, the A's can't be a mine, except for the ones that are already marked. So that means this is not a mine. Now we can have this C. Great. We're nowhere near total mine count on C's, right? There's 13 of them, and I count 10 plus a shitload in the middle. So, I mean, roughly. Okay. So all we got was... this 1 has revealed another mine here. Okay. Didn't really do anything, though. But since we resolved all the A's, There's exactly one in each pair, which means to satisfy the 3s, we need the C and the B on the inside of them to all be mines. So mine, 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 mine. Now there's only one B. Where is it? It's got to be up here, doesn't it? This 4 needs 2 more, and one of these B's must be it. So this is a mine as well, and none of the B's except these that we haven't marked are mines. So this is safe, and this is safe. And of course the bigger one's touching them as well. Now we've made inroads. This 5 has only 5 neighbors, so it needs all those. That should resolve these 3s, right? Yes. This 3 is done as well. This one needs a mine here. That's our last B. 1 goes there. This 1 can only see this square, and this one can see it, so it can't go here. This 1 needs a mine, which must be here. Can't resolve these 2 yet, I don't think. But this 3 has... Does it have one of these 2 A's? I'm not sure, actually. I know I have one of these 2 and one of these 2, but I don't think that implies one of these 2. Oh, but this 1 here does. There you go. So now I can't have this A, and I can't have this C. This 3 needs a mine here. That 1 has its mine now. Ooh, only 3 C's left. We're getting somewhere now. Okay, pencil time maybe? So one of the C's is here. One of them is here. And the other one is here. So these 2 big C's are not mines. Great. Oh, that 1 must be juicy, right? Oh, very much so. Because it's touching these 2 that the 4 sees, so all the rest are free. Now this 3 needs it here. That fills this 4. So we need this as our last mine there. 3 mine. Why is it not done? Do I need to click on something? Oh, this A here isn't clicked on yet? Okay. That was a fun one. Nice to do one without a mistake for a change. We have corners, which means that this 1 and 2 give us this A. Now these 2 together give us this. Mine here, none of these from this 2. This 3 and these 2s should put a mine here, right? The easiest way to prove it would be indirectly, that there can't be one here and there can't be one here. Yeah. Which is in fact true. And the same thing here? Yeah. And again the same thing here. Really making me exercise that 1 skill, huh? Here we go, something new. Oh, hang on. This 2 is from the 1. Column clues don't look interesting yet. 7 in this row out of 10 might be interesting. Oh, wow, only 2 B's left in the whole puzzle. Well, that must be where we're going, right? I can't quite get there yet. There's one of these 2, but then that means there's 1 B somewhere else. I'm betting it's in here. I just have to prove it. How about this 4? Yeah, the 4 is pretty good. Because there's 2 here, but only one of them can be touching this 2. So there needs to be one here. And this 4 and 2 again cooperate to show me there's no mine here. Now, these 2's next to each other give me this whole group of 3. This 2 and this 1 put a mine here. This 1 and this 2 should do something, right? There's 1 mine here, therefore none here. The 2 and the 1, there's 1 here, therefore 1 here. Can't work out what's going on down there yet, I don't think. I don't see anything else going on right now. These 2 will be resolved by resolving this 2, but how do you do that? This 7? Like, surely I'm not ready to use that yet, am I? Because, like, how many spaces are left? 1, 5, 8. We need 6 of these 8? It's not very restricting. Ah, here we go, here we go. This 2 is solved. It's already got these 2. Which means... Wait, that can't be right. Then there'd be neither of these, but then the 1 would be broken. So I messed something up down here. Let's try it again. This 2 goes there. This... Yeah, I mixed up how these were all working together. So this 4 and 2, I did have right, puts a mine here. But now this 2 and 1, there's 1 in this area and 1 in this area, not 2 in the area. So this can't be a mine. Now we get this, which lets us out this way, I hope, right? Yes. These 2 work together to give us those squares. This 3 needs this. 1's done. Nothing there. These 2 overlap here, so that's nothing. I still don't see how to get out through the top, though. Ah, no, of course. Now I figured out the B's. There's 1 B in these 2, 1 B in these 2. The rest are safe. This 3 and 1 put 2 mines here, which solves this 2. This 1's come out ready. 3 there. This 3 and the 2's should be useful, right? Yes, it has to go like, nope. Let's just do it the hard way then. This 3 needs 2. Only one of them goes here, so there's 1 here. Oh, this 2 just sees those. That's the easy way. There we go. Okay. I'm kind of looking at total count of A's and how these columns and rows are all pointing at this, and I wonder if we can make headway there. Oh, no, hang on. There's something easier right now, which is this 2 across from this 3. Only one of these, therefore this, and that's our last B in this area. This 3 gives us these, the 2 is finished. Okay, that's nice. But it's going to be pretty hard to resolve these A's, isn't it? Unless we can show that like all of them are mines, which is impossible, or that none of them are mines, which is unlikely. Because like we've now resolved the entire like area around this island. And we know, for example, that there's 2 in this row on the island, 1 in this row, 1 in this row, and 3 in this row. So like 2, 1, 1, 3. What does that tell me? Not much. I don't think, anyway. Two, 1, 1, 3. So something we do know, I guess, from that is that at least 2 of the A's are on this island. 1 in this row and 1 in this row. Possibly more, but at least 2. And there are only 4 out there, so that's kind of informative. I wish we could use these to narrow it down, because, in fact, kind of interestingly, the ones in these rows are in only these 2 columns, not the central 2 columns. Right? I know there's a lot of lines now. Let's get rid of these, I guess. At least 1 on each of these rows. Which doesn't mean at least 1 on each of these columns, but it does mean at least 2 on these columns in total. But what the hell do you do with that? Ah, here we go. We don't need to work on that yet. This 3 is important. Because it's across from a 2 here. And that 2 has already had 1 thing filled, so this is acting like a 1, right? So this 3 needs both of these, and the 2 can't have this. There we go. 4 still can't resolve what's going on in here. I'll need a count to figure it out, I guess. And interestingly, well, I was gonna say the A count like can't be 1 because then I wouldn't know which of these, but maybe it would be if I could somehow tell the gray count was 0 or was 2 or something. But either the gray count or the purple count will have to be 0 or 2 when I get up here, or I'll be stuck. Good to know, but not immediately useful. This and this work together to give me this square, which works with this 1, so we need something here. This is okay. This 2 and this 1 give us all of the 1's neighbors on the left. There's our last B. Ah, now this 4 might get useful, right? Well, not really. We know there's 2 in the column on this island, but that doesn't tell us anything. Could be both of these A's, could be neither of these A's. Ah, here we go. This 3 and this 1 give us this space. This 2 and the 1 put a mine here, which solves this 2. Nothing there. Mine here. This 3 is done now. Put a mine here. This finishes the 4. Now, the A count is 3. And we know at least 2 of them are on this island. So at most 1 is up here. That's kind of cool. But I don't think we can then say there must be 0, because otherwise I could never figure out the A's. That's a tempting argument to make, but I think it's possible we could work out the gray count, as I mentioned before. So I won't be too hasty by clicking both of these, although I suspect that they're both not mines. Is something going on with this 2 column and the knowledge I have about the island, maybe? I'm not sure. Because, okay, here's my pencil, right? There's 1 here and 1 here. If they were to overlap, that would be quite striking. No. Yes? Yes. If they overlap, that would be striking because... No, I'm saying it backwards. If they didn't overlap, if there were 2 separate mines here and here, that would be pretty exciting because this 2 column would be finished and we would have no mines in this area. And that would give us mines here for the 4 row. Did I somehow make this smaller? And we would also need the last 3 mines here. Okay, that would be 2 more A's. It's not quite enough yet. This 3 would be finished then. We'd have no mine there. How about this 3? Nothing much. This 4, we'd have 1 mine. Oh, actually, I should distinguish between any one of, which I've been doing with a line, or all of these, which I do with separate X's. There. So this is if I make the 2 mines in this area separate. I get all of this. What else do I get? The 4 has 1, 2, 3 mines, so we get 1 of these 2, and therefore 1 of these 2. Then none of these are mines. This... Oh, I was gonna say this looks insoluble because there's no way that I could figure out, like, which of these 2 and which of these 2. But of course, clicking these squares would give me information, so that's not true. So far it all seems plausible. We've then got all 3 of our A mines down here, and we therefore have none in here. So how would we be for this area? How many of these would be mines? How many total mines have we found? 2, 3, 4, 5, 6, 7, 8, 9. 1 of these 2, well, it has to be this one. And then this. So I couldn't find a counterexample here. So it seems possible that the 2 mines for the 2 would be separate here. We would need more information from revealing these squares to help us resolve the island, but it seems like it would be possible. Now, what if we said they're not separate, but they're in fact together? They're just this one. Then we know there's no mines here, but there's exactly one here. We already knew there were 2 in this area, but I don't really know how to pencil that very well. Maybe I'll use blue so I have some space to write the number 2. Is that blue? I don't know. It's pretty awful blue, but sure. And we have 3 in this area. Here we have, in this row we have 1, right? And in this row we also have 1. So we kind of knew the 2, 1, 1, 3 already. But does it somehow interplay with the other stuff that's going on? We know there's 2 there. Or there. And this 3, it also has 2. This is getting a bit tricky. This 4 needs 2 of these. There's no obvious way to resolve the island from here, is there? Maybe that's the issue. If we make the 2 have a mine here, there's no space on the island that you can click. And so you can never solve the puzzle, I think. But let's see if I can prove that. I want to look at total mine count so I can see if this area up here might be resolved somehow. So there's one of these and one of these. Okay. So how many total mines are on the island? We can count that, right? Oh! That's how to figure this whole thing out. I don't need any pencils. I can tell how many mines are here because I know how many mines are on the island and how many mines are on this part of the island. Therefore, how many are on this part, therefore how many are here. I just have to do a little counting. Maybe I'll get the pencil out anyway. No, I don't know. We don't need the pencil. So how many mines in total are on the island is from this, right? 2, 3, 4, 7, right? There's 7 mines on the island. Yes, this is correct. Now, how many mines are on this part of the island? 2, 4, 6. So there's 1 mine on this part of the island, which means there's only room for 1 mine up here, and it has to go there. There we go. Now, all the stuff we had done by pencil earlier and have since erased, we can actually do for real. What was it, though? Oh, no. This was the... This wasn't the one where we could easily resolve the whole island. I've just proven the difficult case. How do I get started on this damn island? Oh, no. I thought I was going to prove that this was impossible, not that it was required. Oh, disaster. Well, I did a bunch of pencil marks and couldn't find anything that obviously let me into the island, right? So what might then be useful is if I could prove that all these A's in the middle are safe, because the A's on the corner make up all the A's in the puzzle. Then I could explore the island, right? And the way to do that would be to work up here. Oh, by the way, I just now realized right-click gives you a different color. Ah! I see. That's what these are about. They're not setting your colors. They're the left and right mouse button. So I can have two colors on the mouse at all times. That's much nicer. I can just put black on left and white on right. Well, it's a little hard to find a good right. So now I can draw black, white. Yes, okay. Wow, amazing. Because remember, we already proved that these corners contain at least two A's. And there are only 3 left. If we could find one up here, we'd be happy. Or if we could find that all 6 of the gray areas or something, gray mines were in here or something like that, we could rule these out. Or maybe only... Oh, well, here's a question. How many mines in total are on the island? We said 7, right? Pretty sure. 1, 2, 2, 2. Yeah, 7. So there are 2 mines up in this corner somewhere. One of them's here, and one of them's here. How do I figure that out? It has to be, like, this 4, I can never resolve these by just this 4, right? Obviously, or I would have done so by now. And I can't resolve either of these by clues from the 4 or from clues I get here, because they're both seeing the same set. So, the only way I could possibly resolve these 2 is by total mine count. And the same here, right? Both of them I have to resolve by total mine count. I can't resolve one and then let that show me the other. I think that means these A's both have to not be mines, and there's a third A on the island somewhere, but how can I prove that? Well, so the reason I think that is because at most one of these A's is a mine. And if it's exactly one, how could I possibly tell which one? I guess I could if I somehow resolved the island. Maybe? No, I still couldn't. Could I? Because it could be either one of these. Like, in that case, there'd be 1 gray and 1 purple mine left. And I wouldn't know if it's here and here, or here and here. Those are indistinguishable to me if there's only 1 mine left. 1 purple mine. And there can't be 2 purple mines. So I think there just absolutely must be 0 purple mines up here. And I'm hopeful that that will somehow let me into the island. I'm going to go ahead and ink that in. This is not a mine. Gotcha. And I still believe the same thing here, right? Well, no. Wait, really? Because suddenly this could be resolved by total mine count. But I only got here by assuming there were 0. Doesn't that mean I can continue to assume there are 0? Even though I can no longer prove it? I guess I can do the proof in reverse, right? I proved that these were both not mines, which proved somehow indirectly that there were 3 A mines here. Therefore, I still know that this A is not a mine. I don't totally understand why that worked. But I just, it has to be true or I can't solve the puzzle. I kind of had a crisis of faith in the middle there. I still, don't get me wrong, don't know how to solve the puzzle, but at least this area is resolved. So we need 3 A's, yeah? And when we looked at them by row, we couldn't figure it out. There was at least one here and at least one here, but there could have been one in any of the other rows. So maybe we can figure it out by column, and then I wouldn't have to do this weird uniqueness argument over here. There's at most, pencil time? There's at most one here. Here, there's at least one. And then in these two, we have no idea. Oh! Okay, that's finally done it. There's at least one in this row. Right? We know there's at least one here, and at least one here, and at least one here of the A mines. So this is safe. And I don't think we could have done that until we proved this area, right? Because we might say, I don't know, there's at least one here. It could be over here. No, that's not true. We always knew this. We always knew this because we're only getting it from the 4. Yeah. So that's why we didn't need the uniqueness argument over here. We could have found it more directly from the island. So this A is safe, and we can use it to explore. In fact, this 3, we don't even need the 4's knowledge because this 3 fills things in. Okay, we do now need the 4's knowledge, I assume, right? Yes. 2 in this column means the 4's last thing must be one of these 2, but only 1. Wait, is that right? Yes, there are exactly 2 in this column because of this 4. So 1 here. So the second, the 4th thing for this column must be here. That doesn't seem to have actually solved it, though. Did we learn anything more? I guess we did. We now know there's exactly 1 on this row. And I believe exactly 1 on this row, right? Yes. And exactly 1 here. That's 3 of our 4 mines in the whole puzzle. The 4th one must be over here, mustn't it? Because we need, this 4 needs 2 in this column. And 1 of them has to be here, so these are not mines. That should do it, right? Not trivially. But the 3 is next to the 1. This 3 can only have one of these 2 spaces, so it needs this one. And this 1 must have one of these 2, so it can't have this one. Now the 4 row is finished. And this 7 row should be finished as well? Yes. Now, the last 2... No, there's 1 in this column. One of these 2, not 2. This 1 gives us a mine here, so this 1 finishes this. Now the 2 row is finished, and the 3 row needs the last mine. Okay, that was a good puzzle. I got it perfect on that one, right? I didn't mess it up? Thank God. All right, on to 51. This 2 is a good starting point. And this 2 expands out to here. Oh, this 1 is finished already. Promising. This 2 sees these. I still wish there was a button I could press that's like, I want to click on a mine, just highlight all of its neighbors for me, because, or not a mine, but like a space. Because I frequently, that's the mistake I make the most, is like not recognizing what a mine's neighbors are or something. This one is finished. Ah, now we've done this column. This one goes there. Oh, I already had that marked. Right. I'd still like a... I love that they put color letters in, but I'd love if it was easier to tell this. I don't see where to make progress up here. This 3 has 4 neighbors. This, I think, could be on or off. Ah, this 1. Here we go. Yeah, this 2's marked, so we need a space there. Very good. Two of these 3 is not quite good enough. This row is almost finished, but not actually finished, which is just about as useless as nothing at all. Ah, but this column's been done. Now we've got more wiggle room. This 4 has 4 neighbors. But I can't go anywhere from this 3, I don't think. How many neighbors does 5 have? 6, right? Yeah. Ah, but 2 of them are bordering on this 3. And only one of those can have a mine, which means the other 4 must all have mines. And one of these has a mine, so the 3's other neighbors don't. That gives us this space is not a mine. This space is. 7. Is that all the rest? 4? Yeah, it is. And that's done the row. This 1 gives us this B. This 4 only has 4 neighbors left. There's 5 B's left. I don't think I can do anything with that yet. Oh, we've already done the 1 column. Yes, fine. And the 2... Yeah. Okay. How about this 5? How many neighbors does it have? Like, kind of a lot, right? The large spaces are octagons. They have 8 neighbors, and I've only erased 1. So, who knows? This 5 has 3 mines next to it and 3 more. So 2 of them must be mines, which means at least one of these 2, which means at most one of these 2. Is that helpful for this 5 somehow? How many neighbors does the 5 have? 1, 2, 3, 4, 5, 6. Ah, and if it's at most one of these 2, then it must be all 4 of the other 4. I didn't really think we were going to get anywhere from this. I just started saying things that were true, and it turned out to help. So now we solved this 2. This 6 should be finished because we've got 2 non-mine neighbors for it. There's only 6 neighbors left. How about this 4? Yeah, both of its neighbors have to be mines. This 1 can't have a mine there. This 3 is finally finished. Still haven't worked out this 5. There's 3 B's left, which is getting close to being important. One of them's here. The other two must be in this kind of diagonal area. But I don't know where, of course, in that area yet. This one we can start with, and this two. And I guess that's where we stop. Didn't get anywhere. This 3, though. It's neighboring the 1, so at most one of these two, therefore here. The 1 needs one of these two for the 3 to be happy, so we get these. The 2 gives us this, clears that up, the 2 goes here. I was rather hoping this would not be a mine, so I'd learn some more about this area and maybe break in that way. But I guess that's not the way the puzzle works. Fair enough. How am I going to resolve this area? I guess I might get a clue about the number of A's that would open this up, but failing that, it's hard to see how I get in, isn't it? No. This 3 means that's a mine. Well, okay, no, it doesn't, because this could be a mine. This 5 has a lot of freedom. This 5... Well, hang on. Maybe we can work backwards from this 5 down to the 5 that got us there. We have these 4, therefore exactly one of these. Earlier, I think we had like at most one. Now we know exactly one of these. Therefore exactly one of these, which means that's a mine. Does that help this 5 somehow? 1, 2, 3, 4. Not really. It does mean exactly one of these 3 is a mine, which could be useful for A counts somehow. What about over here? Still no, right? Right. So, is it really time to make an argument about B counts? How many of these B's? It seems like it could be 0 or 1 or 2, doesn't it? Because it could be like both of these, or it could be both of these, or it could be like these, or it could be these. Can't be this, that's nonsense, of course. But, so I think this area, there's nowhere for it to get information from the rest of the grid. So it must actually be resolved by B counts, which means I can't be thinking about B counts now. I have to get into this area without using B counts. Or this area or something. This 3 means one of these 2. So the 5 needs 4 of these 5, but that doesn't really help, does it? It might. Well, no. This 4 is almost doing something. So we need 2 of these 3. And we know we share at least one with the 5, but we could share just one, or we could share 2. So this area we could break into either with red counts or with this row help. probably the row, if I had to guess, right? We somehow get in over here, and that gets us to this area and also into these blue bees. So let's look at that. How do we get into here? Maybe in here, I guess, is another possibility. This whole area seems like it should be better resolved somehow. I know one of these two for the 2. Which means, therefore, one of these 3? Not sure what to do about that. Alternatively, if I like, I can know one of these 2. Ugh, my mouse slipped there. One of these 2 from this 3. Therefore, one of these 3 for the 2. And furthermore, they can't be both these, so we can put that line there anyway. I also know one of these 3. Ah, maybe that's interesting for this 4. Or 2 of these 3, rather. Aha, that's how we get going. Got it. So this 4 currently sees 2. So it has 2 of these 3. Important note, 2 of those are touching this 2, so it sees at least one of them from this 4. We also see 1 here, which means this side of the 2 is open. There. Now we have this. It still doesn't resolve, does it? Yes, it does. We have one of these for this 2, and one of these for this 2, so this one can't be a mine. And that finishes the 4. And this 3. Got it. So how do we get working in here then? I mean, this 4 has 6 neighbors. It's not immediately easy to tell which ones of them are marked. Help? Like, this 4 doesn't let me in, I don't think. How could it? And what else could? This 3... Okay, maybe that's interesting, actually. This 3 has 4 neighbors. So we have at least one of these 2. And if we could prove the same thing here, we would know this 2 would have no neighbors down the middle. So can we prove that? I don't think so. Because this 4 still has, 6 neighbors, 3 here and 3 here. So it could be these 4, and then the 2 would have nothing here, and we'd have both of these. Or have one of these. Or it could be some other arrangement. Well, I guess we're learning a little bit this way. So we know there's one here, at least one. And that means at most one here. Which means the 4 has at least 3 to distribute among these 4 squares, right? So there's at least 3 there. Which means at least one of these blues is taken up, huh? And we have at least one taken up down here. That's almost enough to tell us something about these blues, but not quite. The 5 column clue is obviously like something that stands out that I don't know how to do anything with right now. And the 2 we're looking at is kind of, it's related to that 5, right? It's in that column. It's controlling other squares that are in that column. I mean, since there's at most one here, we also know there's at most, well, no. Because there's at least one here, we know there's at most one here. Of these 2, but that's not useful. Am I missing something in a different area? I feel like this is somehow like resolvable by someone smarter than me or someone more experienced at this than I am. But I don't see it. So maybe there isn't a solution up here. Well, I guess a question we could maybe ask is, we know there's at least one here. Is it possible that all 4 of these are mines? That would be sort of interesting, wouldn't it? Because we would know then that none of these were mines. And we'd know none of these are mines. And therefore one of these 2 would be a mine. Which I guess I denote like this. That seems possible. I don't see any reason why this couldn't happen. So let's ask a different question. Is it possible then to have like both of these be mines? We'd have one of these be mines. We'd have none of these be mines. Then all of these, none of these, none of these. It's just barely possible, in fact, because no, there's room for 4 more in this column, so that could be done. We could easily fit 3 into the 4 remaining spaces. So that all, like, it seems possible. Is there some argument about count of A's that I just haven't even looked at because 7's a big number? I guess I should take a look. There aren't actually that many A's left in the puzzle now that I look around. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's very suspiciously low. All but one of these are mines? Yes. This 5 is where we have to look. Because it already has 4 neighbors, so it can only have one more. At least one of the red ones must be a mine. So this isn't. And all of the other reds are. That opens up this 2. Finally. Now this 5 has 2 mines and 3 more neighbors. This 3 only has 3 neighbors. We've done this 5 column finally. This 3 is finished here. Now we should be able... the 3 row is done as well. Now we should be able to do this, right? Yeah, 5 has 5 neighbors. This 5... Not sure, but this 3 is done. There. Now this 5 has 4, 5, so that's not a mine. This 4 goes there. You know what would be useful? Is if this said like 7/8 to tell you there are 8 unmarked A's left and 7 of them are mines. I would have found that much more quickly. It looks like there were a lot more A's lying around, you know? Okay, this area... Still not totally sure what's going on yet, but this column should break something open. This 6 has 5 mines already, so 1 of all this. Therefore, this 4... 1, 2, 3, 4. This 4... Okay, we're going to finally get a color argument on B's. This 4 has... 2 more spaces. 2 more mines. At least one of them has to be a B, right? And one of these we know is a B, so that's our only 2. These are not. Oh, I hate everything. Why did you do this to me? What's wrong? Why can't it be... Oh, it could be none of these B's, can't it? It could be here. Oh, I'm an idiot. Okay, well, fair enough. I made a wrong conclusion and I got punished for it. It's just a little annoying because I made it so long ago and it just stuck in my head forever. I didn't go back and recheck it. So what did I click on erroneously? I clicked on this. I should ignore the information from this too in trying to prove everything. I know at least one of the B's is one of these 2. Right? And I don't really see anything else that touches all of these. Shouldn't I be able to do something down here? Yes, of course. This 4 sees one of these 2, and that satisfies the 6, so we can't put 1 here. I forgot to do the other half of that inference. $11 mines. That seems like a lot. Oh, this 3, we know that. These I need color arguments for. Even though I learned by cheating that both of these blues are safe. I'd like to prove it, thank you. It's been a long enough video, maybe I could cheat a little. But I'd rather not. This 2 is working with this 3, so there's at least one here. Which means at most one here. So for the 4 to be finished, we have to do this. There. Now I've proven why I was wrong about B's. Well, not yet. I've proven why I was wrong about this one. I still have to prove that this is... whatever this is. I don't remember now. Oh, it's easy because this 4 only has 4 neighbors now. So that's all the B's. Now this 2 goes like that. Good. This 4 is done. The 3 has 1 here, therefore exactly 1 here. I guess we knew that. This 2, though, is done. And we can mark those. Okay. One slip up. Just didn't have an exhaustive enough case analysis down there. I thought it was one of each color, but that was not the case. Was that number 51? Yes. So 52's up next. And the only ones we've... Oh, no, I'm wrong. It's not that, like, if you haven't done 42, you can't do 52. It's more like if you've done the one above or to the left of something, you get to do it. Okay, well, sure. So we'll do 52 next time. Thanks for watching, and I'll see you next time.